So these are some of the basic parts for the solar powered streetlight. Fairly inexpensive MPPT controller from, I purchased this from Amazon. There's actually links to some of these in this video. Some affiliate links. I do make some money out of all of these if you buy any of them. So the controller is designed for lithium iron phosphate batteries. It will work with lead acid batteries as well. And this has the solar input, the battery output, and also there's also a load output as well, which allows you to control your street light in the absence of solar power. So by default, if you have no solar power coming into this thing, the actual load output is actually switched on. You have the battery you can get from Battery Hookup. If you use my discount code Holden, you will get a discount off of any batteries that you buy. I think currently on their site you can buy these lithium iron phosphate batteries for $30. I've had batteries from them for years, and even though all of the batteries are generally used, they still perform really well in all of my projects. We have the lamp with its kind of bayonet light fitting. You can either buy the lamp holder for these, or you can just solder directly on them. I've chosen in my case just to get the lamp holder. The ballast I purchased from eBay, and to make my life a little bit easier, you might find that when this come to you, they have either some Molex connectors on them or a non-standard connector type. So what I've done is I've actually snipped off all of the main connections here, and then some of them I've just gone and re-terminated. So the high voltage side I've actually re-terminated with spade connectors. I've just cleaned these up a little bit because these will go directly into my solar controller. So let's go ahead and start with the basic build. What I'm going to do is I am going to fix the ballast to the side of the batteries. Let me try and put this in frame for you. So I think what I'm going to do is I'm just going to put this diagonally in the battery. A bit of hot glue is more than sufficient. This will stay here for a while. If you decide to abandon or change the project for whatever reason, then this glue is relatively easy to remove after you're done with it. And the curing time, it's pretty quick. You'll be surprised how many of my projects, or horrified how many projects I actually use hot glue, and it works pretty well for me. So I'll put the solar controller on the side of the battery, I think. I think I'll just put glue on the edge of this, plenty on it. And then I'm just going to bob it down there like that, which is fine. So the wires that I stripped off earlier on, I'm just going to attach these to the load output of the solar controller, so I can see they're marked as plus and minus. I'll start with a plus in here. That's feeling pretty snug as well. And then what I did with these, I actually pre-terminated these with the spade connectors so that they can actually fit my lamp without any issues. That's what we have. That's what they look like on the other end. I actually cut them at alternate lengths intentionally so that there would be less of a chance of a short circuit if the electrical tape that I put around these was to fail. So let me go ahead and plug these in. They don't care about polarity. I think it's an AC supply that's coming out of this ballast anyway, so there's no issue there. Okay, I have a made-up cable actually, which I'm using for the battery. I've marked plus minus. I've actually tested this as well. I've put some spade connectors on here, and I will certainly incorporate a fuse into this as well, because if there was a fault in here, there's actually a lot of current that's available in this battery, and the last thing you want is a fire from it. We've got plus that goes into this terminal here. Now the wire I'm using for the high voltage side is actually quite long. I think you can go quite a distance with it, because this is a high voltage output transformer anyway, that's current limited. So I have probably more than 20 feet, and it's speaker wire I basically use, and it's insulated enough. It doesn't seem to cause any problem. Let me put this upright. I'll connect the minus on here. And these for me are not permanent connections, because I need to get my fuse in here as well. And you can see that the lamp comes on straight away, because there's no input on the solar side. But if we were to apply current to this, then this would start charging the battery, and then it would actually switch this load off as well. So that is very, very basically the solar build. So the only thing that's needed now is for me to attach the solar inputs to this, which we can do now. Let's go ahead and do that. So let's go ahead and do that. It's a good idea to get these cables tightly connected, and it's a good idea to periodically check them as well, because one of the things that I've discovered is that if you have a connection that's not tight enough, then basically these connections start arcing, and then eventually they do burn out. And they can burn out very, very easily. If you see some of the carnage from some of the damaged cables that I have outside, you'll realize how potentially dangerous some of this can be if you have a loose connection. There you are. It feels like it's connected properly in there. This is now ready. We just connect our solar panels directly into this. This battery will probably be operated in this orientation, because now I've got these cables protruding out through the bottom of the charge controller. But you're welcome to sort of mount this, any way that you see fit, and you should be good to go. Anyway, that is the solar streetlight build, and I hope you enjoyed this video, or at least found it somewhat informative. Okay, so this is what it looks like. We've got these two 100-watt Harbor Freight solar panels. I bought these because they have their own stands built into them, and I've just zip tied the whole thing to this cart with a little bit of galvanized, metal work, which seems to work quite well. Now, because there are USB ports on this thing, I do have a camera sat on the front of this thing. I'm going to go ahead and plug it in. Solar's connecting, and you can see on the display there that we are producing power, and the street light function actually went off, so there's no light showing on there. We make more than enough power to be able to power the camera that's on the front of this thing. Keeps an eye on my driveway. You see my street lights off at the moment, which is good. So as soon as it gets dark this evening, that light will come on, and then it will just illuminate this whole area. It's amazing how dark this place is at night time. Here's the parts list. Essentially what we need a ballast to drive the lamp. We need a lamp. We also need a solar controller, and depending on what you decide to do with the lamp itself, you may also need a bayonet adapter. So let's have a look here. So bayonet, it's actually a connector. Just fine. Oh, it looks similar. Okay, so you kind of get the idea. This would probably work most likely. Anyway, let's start with the ballast. So a search on eBay today finds these results. Actually, these look very, very, very much like the ballast that I'm actually using in my project. I've actually got two of these. I bought two on separate occasions. I actually run one of them in my office, which is driving a 34 watt fluorescent lamp. F42, F48. Okay. Yeah, so I think that's your kind of maximum limit really, is probably around 34 watts on this. Now the ballast only seems to draw what the lamp actually needs. It doesn't seem to force power to the lamp if the lamp doesn't need it, which is a little strange to me, because normally fluorescent lamps, at least, I've thought that they basically self-destruct. If you just feed them too much power, they'll consume as much power as you give them, and then they fail prematurely. But in the case of these ballasts, for whatever reason, they don't seem to fail. So the multitude of different fluorescent lights that I've thrown at these ballasts, they also seem to run my 18 watt SOX lamp quite well, and they don't seem to have any issues with it. So the lamp, generally all of these I've found so far, they come with a bayonet fixture. This kit that's here is a 120 watt kit. If you want the lamp on their own, you might get a case of sticker shock for some of these. They cost quite a bit of money, but they do last a long time. They're rated in terms of thousands and thousands of hours. Again, this one has a bayonet fitting on it. This is what that bayonet plug actually looks like. So you've got a couple of choices actually here. You could, if you wanted to, you could just solder a pair of wires onto here, and that would work just fine. If you didn't want to change the characteristics of the lamp itself, you could purchase a bayonet lamp connector. And so there's a few different ones that are available here, although this may be more than what you need. $10, and you've got a pack of 8 of these things. Although this says these are E26, these are not bayonet at all. This is the bayonet here, so $10. Okay, it's only got 1 rating. I usually find something with enough ratings in there that you're comfortable with, and then you've got enough to you basically got enough to go on. You will also need a solar controller.
So in the builds that I have a lithium iron phosphate battery that's connected to a solar controller. You can find these solar controllers that have this appearance, and they look much like this. Batteries get connected first, your solar panels connected second, and then you can wire your 12-volt ballast, or you can run a low powered inverter to the lamp output from the solar controller. If there's no input coming in to the solar, this device can be configured to switch the load on or switch the load off. And so the load that it's referring to here is the output from this solar controller. So that would that in my case works really well. It gets fairly dark before mine comes on, and you could have two 100-watt panels. You might be able to run them in parallel, or you can run them in series. So I have two Harbor Freight panels right now, which I run in parallel. The system is over paneled for its purpose, because I wanted it to make enough power on cloudy days, and it's very rare that the our light will not run throughout the night. In the summertime, it's only running maybe 8 or 9 hours anyway, and in the winter, it's also quite rare that despite the 12-14 hours of darkness that we get here, the system will still run most of the night. For batteries, so typically I will source many of my batteries from here. They don't have to be new batteries. I normally will buy a module, so it'll have a battery management system and everything else. And the closest battery to what I currently have is this 30 amp hour battery with BMS for $30. If you use my link, you can get a discount for it, and yes, I get a little bit of a kickback as well. It helps me pay for these videos.
So this low pressure sodium light is running at full brightness. We have the ballast connected to it, the 12-watt ballast, and we have a power supply that's basically running this at 13.2 volts. So this lamp seems to draw no more than around 1.1 amps. So it's working well within its 18-watt limit. And from a 32 amp hour battery, this is going to run for at least 24 hours before you would ever need to worry about charging the battery. If I turn this power supply off, I can also show you that the ballast is somewhat self-limiting, because you can run other loads on it too. So we can run a regular 8-watt fluorescent tube, and then you'll be able to see how much load is actually drawing from that. Let's turn that on again. So this is an 8-watt fluorescent tube, so this is drawing 0.83 of an amp. So the lamp might be running just a tiny bit over its 8 watts, but I don't think it's going to be significant. I did this test earlier on, and I actually allowed this lamp to warm up fully, and it didn't draw much more than 0.8. It creeps up to about 0.9, and then it stops. And similarly, so we can run a 20-watt fluorescent lamp on this as well, and then that also seems to self-limit on this ballast. So overall, I've been very pleased with this ballast. You do have to be very careful that you don't come into contact with the high voltage output from this thing, because you could get quite a nasty shock from it. So this is a 20 or 22 watt circular lamp. And this lamp is drawing similar to the sodium lamp actually. So this lamp is rated at 20 watts, and then the sodium lamp is rated at 18 watts. So that's one of the reasons why I think that even long term you should be able to run a low pressure sodium lamp on this particular ballast. And I'll be very interested to hear from any of you as to whether you have encountered any issues running a low pressure sodium on an electronic fluorescent ballast. In my experiments with this ballast, I have tried metal halide lamps, mercury discharge lamps, and as you see I've got here, I'm running a high pressure sodium lamp. Now this lamp is actually rated at 35 watts, and as you can see I'm not putting 35 watts through this thing at all. I'm probably putting about 6.5 watts through it at the moment, so it's not going to get very bright. I have tried to run this in another fixture just to warm the lamp up, but I don't know whether the voltage needs to be higher in order for it to get to its full brightness. Not sure I would recommend running or trying to run high pressure sodium lights with this 12 volt ballast. I think as long as you were okay with a quite a low light level from it, it's probably okay. I think the ballast is going to cope with it just fine. Not quite sure how long the lamp would last though.